Welcome friends to my YouTube channel. Now on my last lecture I have discussed about the torsional rigidity, that is the twisting couple per unit angular twist. Okay. Now in today's lecture, with the help of torsional rigidity, we will discuss why a hollow cylinder is more stronger than a solid one of same length, density and mass. This is a very important question. Okay. Now suppose we take the solid cylinder at first. Suppose its length is L, radius is R and density is rho. So what would be the mass? Mass will be pi r square L rho. Okay. And if we consider the hollow one, say inner radius is R1, and outer radius is R2. Okay, and length and density are same, so its mass will be pi L rho R2 square minus R1 square. Since it is given that their length, density and mass are same, so we can make here length and density equal, and later we will also make equal of their mass. Okay, so we can write this for both the solid and hollow cylinders. Okay, now it's given that mass is same, that is pi r square L rho, this equals to pi r2 square minus r1 square L rho. So we can write r square, this equals to r2 square minus r1 square, say give it a name 1. Okay, so from this condition, that is same length, density and mass, we can find out this relation. Okay, now again we know that there is a twisting couple per unit angular twist. Okay, so for solid cylinder we can give it a name C solid, that is the twisting couple per unit angular twist. Since the radius of the solid cylinder is R, we can write C solid, this equals to this. Okay, and what would be C hollow, that is the twisting couple per unit angular twist for the hollow cylinder, that is length is same and their radius is this is the outer radius and this is the inner radius. Okay, so this is the relation. So if we divide these two, okay, if we divide these two, then what we get, that is C hollow by C solid. So what we get R2 to the power 4 minus R1 to the power 4 by R to the power 4. Okay, so we can write this as R2 square plus R1 square, R2 square minus R1 square by R to the power 4. And previously we found that R2 square minus R1 square equals to R square, so we can substitute this. Okay, so we get R2 square plus R1 square by R square. So this term is greater than R square, so obviously C hollow is greater than C solid. So we see that the twisting couple per unit angular twist in case of a hollow cylinder is greater than that of the solid cylinder. That means the moment of the applied couple or the applied twist for the hollow cylinder is greater. So that means more and more energy will be stored in the hollow cylinder than the solid one. Okay, and if more energy is stored in it, then it will be more stronger than the solid cylinder. Okay, okay, so twisting couple for hollow cylinder is larger than the solid one. This means more energy will be stored. More energy will be stored in the hollow cylinder. Okay. For this reason, hollow cylinder is more stronger than the solid one. Okay, so this is basically a conceptual question regarding the torsional rigidity. Okay, now in my next lecture I shall going to discuss another issue, that is the bending of a beam, and thereafter I will discuss the light cantilever. Light cantilever is only the syllabus only includes light cantilever, not the heavy one. So at first in my next lecture I will going to discuss the topic, that is the bending of beams. Okay, bending of beams. Okay, so dear guys, if you don't subscribe my channel, then kindly subscribe it, and if you have any query, then just write it in comment section. I will be ready to give the answers that I also gave in past. Okay, and video link will be given in the description box. Okay, thank you.